So now let us see what are the essential mineral elements. Now, the essential mineral elements, most of the mineral elements can enter the plant through the soil. And because they are coming from soil, we call them as mineral elements. Okay. So, soil is the major source. In fact, more than 60 elements are found in the plant kingdom. When we talk about the elements that are present within the plant or used by the plant, there are almost 60 throughout the span of the entire plant kingdom, right? But all the 60 are not very important. You can see few whose deficiencies we can very clearly see in a plant. For example, if there is carbon dioxide deficiency, you will see that dark whitening of leaves or death of the plant. If there is manganese deficiency, you will see one type of symptoms and all. Few symptoms are very visible also, which makes it very, very useful, which makes that element very useful. Okay, there are some, as I've said, gold, selenium, uranium, strontium. These are all not needed for the plant, but they have been found in the plant. Okay, they've been found in the plant. Selenium was found in the plant. Okay, why? Why is it so? Why is gold being found in the plant? Gold particles. So, in fact, they were as low as a concentration of 10 to the power of 8 grams per ml. They are not even found in high concentrations. They were found in very, very low concentrations, but still they were present. Why? Well, the answer to this question is that the plants, because they absorb majority of the minerals from the soil, if they're growing in an area whose soil is already rich with these minerals, then these particles like selenium, let us say the plant is growing in a radioactive area. If it has got selenium or strontium, if it's growing near a nuclear power plant, then if there is selenium or strontium that is used there, the soil will pick up those minerals and the plant also picks up them in the very minute quantities. Similarly, plants that grow near the gold mines or gold areas where there are gold ores, because the soil itself is rich with gold in the particle, in the ore form, the plant also picks it, but in a very, very minute quantities. So, but we can't say that selenium, gold are very, very important for the plant to survive. No, they are just there because the soil is rich in that. So, we need to identify a criteria of essentiality. You can't say that just because selenium is present, selenium is important, strontium is present, strontium is important. No. We need to identify out of those 60 elements that are present throughout the plant kingdom, how many are actually essential for the growth, the survival, the development and the reproduction of the plant. So for that, a criteria of essentiality has been supplied. The first criteria is that the element must be absolutely necessary for supporting the normal growth and reproduction. In the absence of the element, plant cannot complete their life cycle at all. Means this element is so important that the major activities of the plant life cannot happen. The plant cannot even imagine that the major activities will happen without this element. In fact, if this element is not there, it will not happen. So that is the first criteria for the essentiality. So among them, then you have many. Next, the second criteria will narrow our pyramid a little lower, because what happens is, in the second criteria, we talk about the fact that these elements are non-replaceable. See, for example, let us say you're cooking in your house and you're out of table salt. What are you going to do? You're going to use black salt or you're going to use pink salt. There's so many salt varieties, right? So instead of your common table salt, you can use any other salt. But adding salt is important. Let us say you're making a dish and you need tomatoes for the dish. If tomatoes are not available, you replace it with yogurt or curd, right? So it basically gives the same effect. But in this case, you cannot replace it at all. Means if let us say an element is absent, you cannot ask another element to replace it and say, you please go do its work. It's not going to happen. Whatever element is there, it is specific, its role is specific, and nobody can replace it. And if, let us say, that element is deficient, you cannot give another element in excess and say, no, this will cover that fellow's deficiency. It's not going to happen. So the second criteria is that the elements must be absolutely specific and irreplaceable. Now, coming to the third criteria, the element must be directly involved in the metabolism of the plant. If I set up an organization and I sit somewhere some 100-200 kilometers away, let's say I've set up some organization in Bombay and I'm sitting all the way in Kerala, and I say, well, why is that not working? Why is this not functioning in that organization? Nobody is going to listen to me, because my effect is not direct. I'm sitting somewhere, I'm not directly involved in the organization. I come once in a day and I ask the report. It's not going to work like that. My organization is going to fail. If my organization has to work, I have to sit there, I have to directly be a part of it, coordinate everything and do the work. Same logic applies to the plant. Whatever element I'm taking, it has to be directly involved in the metabolism. Otherwise, there's no point of it. Right? So these are the three criteria. What are they? It should be absolutely necessary, it should be specific and irreplaceable, and it should be directly involved in the metabolism. So these are the three criteria of essentiality, and based on these criteria of essentiality, you can identify what are the main essential elements that are required for the plant for its survival, growth and development, and what are the ones which are non-essential, which the plant can somehow manage even without them. So these elements are, as a result, you have found elements, and again those essential elements also were further divided into two categories, macro and micro. Now what is this? Well, this is based on the concentration. Let us say if some essential elements are required more in quantities, we'll call them macro. If some are required in less quantities, we will call them micro. Okay, so macronutrients are generally present in the plant tissues in excess amount. What is that amount? There is a specific amount also that has been identified, which is 10 nanomoles per kilogram inverse of dry matter. Okay, now, so if any nutrient is required by the plant tissue for more than 10 nanomoles kilogram inverse of dry matter, then we call it as a macronutrient. Then what is a micronutrient? Okay, before we go to that, let us see what are the macronutrients. The macronutrients are carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, potassium, calcium and magnesium. So how many are there a total? So they are a total of, let us count them, 1, 2, 3, 4, go on, do it everyone. Let's count the micro elements. So their number is 9. So you have 9 macronutrients that are required by the plant. Now in those 9, carbon, hydrogen and oxygen, they are the framework elements, and they are not absorbed from the soil directly. Okay, they are absorbed from carbon dioxide and water. Oxygen is coming from gas, carbon dioxide, water. So carbon, hydrogen and oxygen, they are taken from the gaseous form, they are not taken from the soil. So basically the other 7, how many are there? The other 7. What are the other 7? Nitrogen, phosphorus, potassium, calcium, magnesium. So these other 7, they are absorbed in the mineral form. So those 9 are the essential macro elements. They are the essential macro elements. Whereas if you remove carbon, hydrogen and oxygen, the rest 7 are called essential mineral macro elements or macronutrients. You understand the difference, right? When we use the word mineral, that means it is coming from the soil. Okay, so carbon, hydrogen and oxygen is coming from the air, and the rest are coming from the soil. It's very clearly, it has been demonstrated. Now Next, what are micronutrients? Micronutrients are also called as trace elements, and they are required in very, very small quantities, less than 10 nanomoles of kilogram inverse. So, these are iron, manganese, copper, molybdenum, zinc, boron, chlorine, and nickel. So how many are there? Let us count them. All of you please count it. They are 8. So you have 8 micro mineral elements. All of them are coming from the soil. So these are micro mineral nutrients. Okay. Now, so in additional to these 17, so what are those 17? How are they? How did we get the 17 first? Let us see that. You have 9 macro plus 8 micro elements. Together they form 17. So how many essential elements are actually out of the 60 in the plant that uses? The criteria of essentiality has given us 17 essential elements. Out of these 17, 14 are mineral elements which are coming from the soil, and the rest 3 are coming from the atmosphere. Okay, so other than these, you have beneficial elements in the form of sodium, silicon, cobalt, and selenium. Yes, as I've said, selenium. They are required by higher plants like angiosperms and gymnosperms. So sodium, silicon, cobalt, and selenium. Now, why are they called beneficial elements? Well, they're called beneficial elements because they help, they provide or give extra benefit to the plant, but even if they are not there also, it won't hamper the plant's growth and development. They are not very essential, but if they are there, they will give an added benefit, an added advantage. It's like if you drink milk, it's good, but if you add some boost in it, its boost has got some more nutrients which will give an added advantage. But if boost is not there, that doesn't matter as long as you're drinking milk. Same logic applies here. Okay, so essential elements can also be categorized into more categories. So we know that there are 17 essential elements which we categorized into the macro form and the micro form. There is another way to categorize them. The first category is they are structural elements of the cell. For example, if you take the case of carbon, hydrogen, oxygen, nitrogen, they are present in all biomolecules. Biomolecules like what? They are present in proteins, they are present in nucleic acids, they are present in lipids, they are present in polysaccharides. So all of the major biomolecules, go back to the biomolecules chapter 1 so that you will get an idea. All of them contains carbon, hydrogen, oxygen and nitrogen. So they are basically the structural elements of the cell. So all these 4 elements can be put under the category of structural elements. Okay, the second one is the elements that are required for energy production. What are those? Magnesium. Now, magnesium can be used for energy production. How? Magnesium is also a structural element because it is present in the structure of chlorophyll. If you look at the photosynthesis chapter videos, we have discussed structure of chlorophyll there, where we have seen that the 4 pyrrole rings are held together by the magnesium. And this chlorophyll is necessary because what it does later on when during photosynthesis, this chlorophyll only is going to create that excitation of electrons which help in the production of ATP. So there is energy related production that is happening because of chlorophyll. So that way magnesium is important. Another one is phosphorus. In fact, ATP, the word itself is adenosine triphosphate or adenine triphosphate. So phosphorus is very, very important in ATP, which is the energy currency of the cell. Okay, so there ATP has 3 phosphates, right? So the next one, The next one is an activator or an inhibitor of enzymes. Now, in the biomolecules chapter, we have dealt with the topic of enzymes, and we have said that they are biocatalysts which need to be sometimes activated and sometimes needs to be inhibited. Now, there are certain mineral elements which act as activators of enzymes and some act as inhibitors. For example, magnesium ion. Magnesium ion is an activator for rubisco, rubisco, ribulose, biphosphate, carboxylase, oxygenase, and it is also the activator of the enzyme peptidase, which is nothing but